Hey, Joanne here. So today I wanted to talk to you about transposing formulas. And there are three specific rules to transposing a formula. So the first thing I want to talk to you about is a formula that is found to be in direct proportion, meaning if one variable on the right hand side of the equation is held constant, an increase of the other variable would cause the exact same increase in magnitude on the variable that's found on the left side of the equal sign. So a direct proportion formula would be a formula that does not include a division variable or does not include a denominator. The formula that I have here for you is an Ohm's law formula. E equals I times R. So if you had a variable of resistance held constant and you increased the I, the E value would increase proportionally to the amount that the I value increased. This formula is in fact direct proportion. So if I wanted to solve or isolate a variable of this formula, I would have to apply the first two rules to transposing. Let's solve and isolate I. What I mean by isolating and solving I is that I want to get the variable I, which is current, on its own. In order for me to get current on its own, I need to get rid of the variable R, known as resistance. So that would have me apply the first rule of transposing, and that is opposite function cancels. So currently the variable I is being multiplied to the variable R. In order for me to isolate I need to get rid of R. To get rid of R, I would apply the opposite function to multiplication. So the opposite function of multiplication would be division. So we would have to divide by R. That effectively cancels the R value, which would then bring me to the second rule of transposing formulas. What you do on one side of the equal sign must be done on the other side to maintain balance. The formula E equals I times R is considered a balanced formula. If we are to remove R from the right-hand side of the equal sign to maintain balance of the formula, we have to do the same thing on the other side. So effectively, we have now isolated and solved for I. I equals E over R. To recap, when transposing a direct proportion formula, you apply rules 1 and 2. So to isolate and solve for a specific value, you would include or apply the opposite function to the existing variable, and then whatever function you performed on the one side of the equal sign, you must do on the other side to maintain balance for the formula. The next thing I want to talk to you guys about is when your formulas are not in a direct proportion, rather they are in an indirect proportion. So a formula that includes a denominator or a function of division. So you can see here that I'm going back to our Ohm's law, I equals E over R. We in fact have indirect proportion. So in the event that resistance was held or voltage rather was held constant, an increase in resistance would cause a decrease of the same magnitude in our variable on the left side. So if our voltage was held constant, had an increase in resistance, we would see a decrease in current of the same magnitude. So we would have in fact indirect proportion. So in this particular formula, I would now like to isolate and solve for the variable of R, the variable of resistance in the formula, meaning I want to isolate R, I want R to be on its own. That means I need to get it by itself. So I cannot apply the first and second rules as previously mentioned. I cannot just start performing opposite function cancels, and I cannot apply what I do on one side and must do on the other because of this indirect proportion. The very first thing that I need to do to manipulate and isolate R is to take this formula and make it a direct proportion. And to do that, I simply cross multiply. The variable I on its own is the same as I over 1. And I like to put that in there just for the visual of cross multiplication. So we will perform cross multiplication where I would take the R and bring that to the I, and then bring 1 up to the E. So that would in essence look like I times R equals E times 1. E times 1 is just E on its own. Okay, so now you can see in this formula that I have in fact taken an indirect proportion, cross multiplied it, and brought it to a direct proportion where we now can apply rules 1 and 2. Again, we are looking to isolate the variable of R, meaning we want R to be on its own. In order for R to be on its own, we need to get rid of the variable I, and to do so, we would have to apply the opposite function. So the opposite function of multiplication is division. So we would divide it by the variable that we're looking to get rid of. So we want to get rid of I, so we would have to divide by I. So that is applying the first rule. So we have now gotten rid of I, but we no longer have a balanced formula. So we have to apply the second rule being what you do on one side of the equal sign, you must do on the other. That would indicate that I would have to also divide by I on this side. So effectively now we have isolated and solved for R. R equals E over I. So using these 3 rules of transposing, you can effectively solve for any unknown variable. It's very important that you have this skill in the electrical training as you're using a lot of formulas and asked to solve for unknown variables specific to the circuits. Hopefully this helps. Thank you.